I'm really happy to be here and really happy to talk to you guys about something that is very, very near and dear to my heart, which is my company, but it's also photography. And when Stephanie wrote and we were talking about this conversation or having this talk, this topic of big data came up again. And I have a bit of a bias because I have my very own personal understanding and belief of what big data is. By show of hands, do you guys know what big data is? Do you have an idea of what big data is? Nope. All right. So big data is a big buzzword, really. It's sort of the Web 2.0 version of 2015, 2014. It's something that basically the press can consume. It's like a little bite that the press can consume. And the reality is there is no such thing as big data. There's just data. The only change is 20 years ago, you had a floppy disk with 1 megabyte. 10 years before that, you had a floppy disk with 500 kilobytes. Now you have an external hard disk with 2 terabytes. But that's not big data. What big data really means is that if we think of Moore's law, if we think of this theory that every couple of years, things get twice as fast or twice as cheap when it comes to technology. That is really the only explanation and the only definition of big data. Because all that means is we can process hundreds of terabytes today in seconds. A few years ago, we needed hours. A few years before that, we could never do that. And I mean, this simple example that everyone talks about of the Apollo project, the computers that basically put a man on the moon had just a small fraction of the computing power of your iPhone. That's big data. So what I want to talk to you about today is what we do with data vis-a-vis photography, and what we at EyeEm do with how we use big data, or how we use sort of a lot of computing power and a lot of calculations and a lot of data points to understand photography better. To do that, I kind of need to tell you what EyeEm is. Does anyone know what EyeEm is? No, fantastic. So EyeEm is a Berlin-based photography company. We started this company 4 years ago with the premise that we wanted to build a playground for a new generation of photographers. 4 or 5 years ago, if you remember, was sort of a turning point. People were starting to use their phones to take photos. They were starting to use their phones to actually take and upload photos right away. And we realized that that kind of photography is just as good as other sorts of photography, but it didn't have a place where it belonged. And that's what we built. So we started with a little photography competition, the world's first mobile photography exhibition, did another one in New York. We grew basically the community from the 2,000 photographers that started in day one to something like 15 million photographers today, all over the world. And we grew it in the premise that it was about the passion for photography. We didn't want a social network. We didn't want to build a place where you take a photo, add a couple of filters to it, upload it, share it to Facebook, and then know your friends with photos of your feet or photos of your food. I mean, that was like a really great idea by Instagram, but we wanted to do something different. We wanted to build a home where you, as a photographer, can discover other photographers, where you can become a better photographer, and where you can learn the trade and actually just develop your skills. And that sort of was the journey that we took over the last 4 years. Like I said, millions and millions of photographers nowadays use EyeEm as their home. And the cool thing is, what we realized was a lot of them started asking this question: what is after my next like? What is, does that quantify me? Does the number of likes I get on a photo and the number of comments I get on a photo, is that the value of my photography? And they were looking at other avenues. They were looking at things like the offline exhibitions that we do. They were looking at giving master classes, giving talks, becoming professional photographers. And at the same time, we had a lot of brands, a lot of agencies coming to us and going, this kind of imagery that you have is very distinctive. It's not the typical stock photography. It's not the typical very, very posed, very structured, well lit, but it's really natural. It's very authentic. And is there a way that we can engage with this community of yours? And that sort of got us on the track of thinking, well, let's build a way for photographers to make money, for brands to get access to this new generation of photographers, and for us to make some money on the side as well, without having to sell our user data and without having to sort of show ads and do all that stuff. And that's the idea what which became our marketplace and which became our missions platform. And it's grown really big. Has anyone here heard of Der Spiegel? No. So you guys just don't answer at all. That's the point. OK, cool. So Der Spiegel actually runs a thing they call the Sechserpack. Every week, they have like 6 photos that they source from EyeEm. And the idea is that one of my favorite examples ever is they were running this article on sort of like absurd EU laws. And there's this one law a while back about the shape and the curvature of a cucumber. So what they wanted to do was they wanted to sort of visualize that. And they realized that it was ridiculously expensive to do it by sending professional photographers all over Europe. And they reached out to us, and we talked to our community. And we're like, hey, guys, we need photos of cucumbers in front of national landmarks. And within a few hours, we had a guy holding a cucumber in front of the Eiffel Tower, another guy in front of the Bundestag, someone in Brussels, someone in London. And they did like this really beautiful collage out of it. And basically, how we look at EyeEm is we have these 3 pillars. The first pillar, the heart, the soul of the company, is the community. And we would do everything for our community. The second pillar is the marketplace. That's where we allow our community to grow, to become professional photographers, and where we allow brands and agencies and publishers and so on access to that content. But what happened was, we're talking about tens, hundreds of millions of photos. We're talking about a huge volume of data that just cannot be done manually anymore. We can't process it manually. We can't keyword it manually. We can't search for it manually. And we realized we had to sort of develop the technology to do that. And this is sort of what I wanted to talk to you about today. I won't go very deep into technical stuff, but I will just be on a very high level. On a very high level. And worst case, you can close your ears. There's a whole lot of fun photos. You don't need to listen. Just look. This photo is actually one of, the next 3 photos are more or less my inspiration for being part of EyeEm. This one is a photography exhibition or is an art installation, sorry, by Eric Kessels. What he did was back in 2008, 2009, I think, he printed every single photo that was uploaded to Flickr, which was the biggest photography network back then, and just threw it around in a room. And I don't know why he did it. Who knows why artists do what they do, but for me, that sort of signifies something that we call the digital nirvana. It just signifies the fact that all of this content just gets lost. And really, there is no way, using human skills to actually understand and be able to absorb all of this content. The second photo, I think it was from 2007, 2008. A plane crashed in the Hudson River. Captain Sully is now like one of those superheroes. And I think this was a turning point for social media because before the press got there, before journalists got there, before anyone got there, people were uploading these photos from their phone and sharing them on TwitPic and other services, getting shared on Twitter. And this photo, this photo made it around the world within minutes. There were tens of thousands, hundreds of thousands of people sharing this photo. And this is not the best photo, but it's contextually very, very relevant. Which brings us to the second, or the last photo. The photo on the left is by a really famous American photographer called Dorothea Lange. And it's a photo from the Great Depression in the US. It's a mother, I think it's called the Migrant Mother. It's a mother and her 2 kids or 3 kids in some farm in California trying to make do. The photo on the right is from someone you've never heard of. It's a photo that you've probably none of you have ever seen. And it was a photo taken 5 years ago by a French photographer of Romas as they were being evicted from their homes and being sort of sent away out of France. And this sort of, again, brings us to the question of context. I personally think the photo on the right has just as much aesthetic merit as the photo on the left. The only problem is the photo on the left was taken at a time where there were maybe a few thousand people who had cameras, where there were maybe a few dozen thousand photos taken per year. The photo on the right is taken at a time where pretty much every year more photos are taken than in the entire history before that. I think this year something like 1 trillion photos will be shared, and maybe 5 times, 10 times as that will be taken. So this is sort of what our mission is. By looking at these 3 photos, our mission is to make sense of this stuff, to understand photography. My R&D team basically focuses on 2 things. They focus on finding beautiful photos, and they focus on understanding what is in those photos. And this is what I sort of want to talk to you about today. But before we get into that, again, nice, interesting art projects that I personally found very inspiring. So there's this crazy guy somewhere in the States who has this massive computer program running that is basically taking a 640 by 480 black and white frame and running every single combination of pixels on that frame. And it looks like dots. It looks like black and white dots. But the fact of the matter is, when this completes, this will never complete because the sun will swallow up the earth before it's done. But when this completes, every single photo that was ever taken or will ever be taken or anyone could ever conceive of or have potentially seen, every single moment that you have experienced in your lives would have been emulated on a computer screen automatically. And that sort of, to me, is really a big part of the driver of actually being able to claim we can use machines, we can use big data to understand beauty in photos and to understand what's in photos. And this is sort of the technology that we're building. So we have a couple of huge algorithms that actually look at a photo and say, this photo is beautiful. This photo is not so beautiful. This photo is pretty bad. We have a bunch of other algorithms that look at it and say, there's a dog, a tree, a bird in this photo. This photo has negative space in it. This photo is symmetrical. This photo has a bokeh, and so on and so forth. But we also know who took the photos. So we also know where that person came from. We also know what people feel about those photos because they're part of a social graph. And at the end of this, we get to a point where you can actually say, you give me a photo, and I'll tell you this photo was taken by a 16-year-old tourist from Japan who was visiting Berlin on a rainy summer day, and the photo was taken at Weinbergspark, and there's 2 dogs and 1 tree, and it was an actually beautiful day, and there's people celebrating in the background because Germany just won the World Cup. And all of that data I can just extract from the pixels and from the relevant metadata surrounding it. So to sort of move forward, I want to tell you just a little bit about how we understand photos, how we understand what's in photos from a machine side of things, and then focus a little bit more on the beauty, which I think is the more interesting question. Because recognizing that there's a dog in a photo seems relatively easy. I mean, it's quite challenging, but it seems relatively easy. Recognizing that it's a beautiful photo of a dog is, definitely way more complicated. So maybe a very brief explanation of the technology that underlies this whole thing. It's a field of computer science called machine learning, deep learning. And the very rough idea is you have a really, really big machine, or actually a cluster. You have hundreds of machines. And you tell these machines, these 1,000 photos are photos of a dog, or actually a specific breed of a dog. And these 1,000 photos are not photos of a dog. And the machine just looks at all of the photos, understands the pixels, tries to analyze them, and then starts making guesses to a certain level of accuracy. Sometimes it's very inaccurate in the beginning, and we have to train it a little more. Sometimes it learns pretty quickly. Sometimes we can actually teach it things. So there's always these interesting surprises. For example, one of the very first iterations that we built confused cowboy boots with tattoos for some reason. And you never know why, because it's not a human brain, it's a machine. But we've taught our machines to actually understand tens of thousands of different concepts. And if you take that image recognition stuff and you add the user-generated data to it, so you add the keywords, the hashtags that you guys use, you add the colors that are in the photo, you add the format, what filter you're using, you add sort of where the photo was taken. If you know where the photo was taken and when it was taken, you know how the weather was like at that day. You know what events were happening nearby. So suddenly you can actually look at a photo and not say this is a concert, but this is a reggae concert because it's taken at a place that had a reggae event that night. We sort of built this thing and we call it Oculist. And Oculist is basically the framework that we use to train and understand image recognition concepts. And Oculist looks at 4 different things. The first one are the very concrete stuff: car, dog, tree, woman, tattoo. Then it gets a little more abstract. We teach it how to understand something like vacation. And again, it's a pretty interesting question because in Europe we say holiday, in the States we say vacation. And if you're from the US and you're saying, show me holiday, you actually want to see photos of Christmas and Halloween. If you're in Germany and you say holiday, you want to see photos of happy couples on the beach. And our system will understand these differences. Then you go into sort of the photographic aesthetic aspects of it, like golden third, negative space, symmetry, and so on. And then finally, you start understanding the relationships between the various concepts in a photo. So suddenly our algorithm looks at a photo of a puppy and it says, this is love. We're there. It's kind of scary, but we're actually there. So we look at photos and we understand pretty much everything that's in them. We look at a photo and we see there's a whiteboard, there's a table, there's a chair, it's taken at night, blah, blah, blah. If we want to market these photos, if we want to basically allow people to sell these photos, knowing how many people take really bad photos in this day and age, we realized that the bigger challenge was understanding beauty in photos. So just to put this kind of in perspective, for every single photo that we analyze, we do something like 500,000 to 1.5 million calculations in milliseconds. So that's the big data part, and I won't go much more into detail on that. But to understand beauty, we basically have to ask ourselves, what is common between these two photos? I think these are both pretty beautiful photos, or pretty good photos at least. I mean, the one on the right, we can't argue, it's Steve McCurry. The one on the left is a photographer on EyeEm. But then the question is, what is the difference here? And effectively, I'm not going to go into this formula, but effectively, what we're looking for a space between the two photos that are both beautiful and the two photos that are very different, to actually be able to say, photos that are in that space, that are close to each other there, are both beautiful. And the photo that's over here is not that beautiful. And while doing this, we looked at a whole bunch of different things. Our R&D team looked at a bunch of research happening in that area. We realized a few different things. We realized, first of all, that it's kind of easy to say a photo that is symmetrical, a photo that has a bunch of parameters is beautiful. But the fact of the matter is, a lot of beautiful photos do not have these rules. They break the rules. And then it's about the emotion. And then it's about the feeling that you get when you look at a photo. This photo, I mean, Raghu Rai is one of the very famous masters of photography, I would say. A year later, Sebastian Salgado took, by the way, you should go check out his exhibition at CO Berlin if you're into that. Anyway, he took a photo at the same train station, and you see this very similar aesthetic to it. Randy Olsen did the same thing 7 years later. Again, there's a reason why these guys take a very similar photo. They know what is beautiful. They know what moves us. It's the exact same station. It's not the exact same photo, right? But again, motion blur, symmetry, so on and so forth. What about photos that are way more abstract? What about photos that don't follow these rules? Photos that are blurry? What about Robert Capa's photo of the invasion of Normandy? In a technical sense, it's crap. In an emotional sense, it's amazing, right? How do we understand the story behind the photo? Again, Antoine D'Agata, very famous photographer. How do we get that? What we realized was there's a field of study called neuroscience, which I'll get to in a second. But what we realized is that there is something when it comes to patterns. And these three photos look similar. One of them is of a canyon. One of them, the other two are of women with their hair going up in the air. But there's something similar. There's a similar dynamic. There's a similar emotion that is elicited. And there's a similar sort of structure. And it's actually that which is beauty. So neuroaesthetics, neuroscience is a field that studies this. And a subsection of it called visual saliency, which is a really complicated thing that I don't personally understand, is the study of how we perceive things before we perceive them. So how you look at something, and the first impression within milliseconds is, this is beautiful. And then you start realizing, oh, there's a tree there, and there's a background, and I see the colors, and I see the setup and structure, and so on. But the fundament is, you look at something, and instantaneously, you know if it's beautiful or not, if it's aesthetically pleasing or not. And this is sort of what we've been trying to mimic. We've been trying to mimic how the brain recognizes this within a split second and makes that decision. Something is beautiful. Of course, if you want to analyze aesthetics, you can look at sort of the various compositional elements of a photo. You can look at the vanishing points. You can look at the interplay between the different objects. You can see sort of the sign and the hand are different sizes, and there's sort of that lack of dimensionality between them. There's the vanishing points of the road, and so on and so forth. But all of that happens afterwards. And what you want to do in the beginning, in the very, very beginning, is understand that split-second reaction. And how we did it was we actually looked at the masters. We looked at all these famous photographers, all these talented photographers, new and old. David is actually 15 years old, and he's a ridiculously talented photographer. Elliot Erwitt, I guess, needs no introduction. And then we also looked at the bad photos. We looked at what people want to avoid. And I mean, there are certain rules, right? You will argue that one photo is nicer than the other, but I think all of us will struggle to say that the photo in the middle is an aesthetically pleasing photo itself. I mean, you might like the guy or the girl, but yeah. So what we realized was it is essentially a matter of pixels, right? And we come back to the idea of the one single pixel. And how we do it now is we actually look at clusters of pixels. And we've taught our algorithms to look at a bunch of pixels, contrast them with other pixels somewhere else, take different sized snapshots of or sections of pixels or superpixels, and sort of try to relate them to one another. And we have a lot of data in the background that tells us when this and that and that and that happen. That's a very simplified way. When these factors are met, you have a beautiful photo. I had a video here, but unfortunately, I can't show it. It's basically a curated collection. So one thing we do at EyeEm, we do a yearly photography festival. And it's actually the largest photography competition in the world. So we get something like 150,000 photos submitted to that festival. What we did last year was we actually used this algorithm to curate the best photos. And if I could show you the video, you'll have to believe me. But if I could show you the video, you'll see that there's basically a selection of 50 ridiculously beautiful photos that that just show that machines can actually understand beauty, right? Which sort of brings me to my conclusion. Why are we doing this? We basically, as a very, very short-term goal, if we want to make hundreds of millions of photos available for search, we need to be able to make them searchable. We need to be able to give them the keywords. We need to be able to allow someone searching for photos to find what they're looking for. But if we sort of extrapolate that and look at the bigger picture, every single photo that's being uploaded, be it photos that you're taking on your phone, be it photos that you have on some hard disk somewhere, be it photos on Google, whatever, we can't search naturally, not yet. And I think the only way we can search naturally, the only way we can search for a photo the same way that we think of that photo is by actually teaching machines to understand photos. And this is our mission. It's a very, very ambitious goal. I think it's a lot of fun. It's definitely a huge challenge, and particularly when you speak to photographers, for example, if you tell them that I have an algorithm that can judge your work, not necessarily something you want to say, and not necessarily something that is actually true. But I think we're at a point, particularly due to cloud computing, and particularly due to the fact that we can boot up hundreds and thousands of servers to run massive calculations that just 5 years ago were practically impossible. We're at a point where we can actually index every single photo in the world. I think that's it. So. Thanks.